Okay, so we are going over solving systems of linear equations with multiplications. Okay? If we're going to sit here and have giggle fits, then go out in the hallway and have the giggle fits. It's a little ridiculous. Yeah. Okay, so I am going through the problems that you had 6-4 for homework. Sorry, I had walked to the back of the room, so I don't know if the sound picked up. I'm going over the problems that you had for lesson 6-4 on the homework, which was solving systems with multiplication. Okay? And a lot of students get very confused as to how to start this because there are so many different ways that you can start it. Yes, I'm recording the video. What can I do for you?
Can I have the review packet?
Okay. So we had two equations. X plus y equals -9, and 5x minus 2y equals 32. Now to solve by elimination, which is what we did the prior class, lesson 6-3, I need to have one of the variables in the equation have either the same coefficients and then I can subtract, or opposite coefficients and then I can add. I prefer to always have opposite coefficients so that I can add them, add the two equations. So a lot of students say, I don't know what to do first. Part of the problem is there's two different things you could do first. You could multiply the whole first equation by -5. That would give you -5x minus 5y equals +45. Because -5 times -9 is +45. So you could do that. Then your x's are going to cancel out. You're going to solve for that first. Or, because the y's, one is already positive and one is negative, that's what I would do first. And I have to multiply by 2 then. That's going to give me a +2y and a -2y. So I'm going to go ahead and multiply it. I'm going to get 2 times x is 2x. 2 times y is 2y. And 2 times -9 is -18. This allows me to have one set of coefficients, variables, the y values, cancel out. I'm adding. Some students get confused and they say, well, Mrs. Fogg, am I adding or subtracting? Well, what do you need to do to cancel those out? If you get confused about adding or subtracting, just think about it as combining like terms. Combining a -2y and a 2y will cancel them out. So combine a 5x and a 2x. You get 7x. Combine a 32 with -18. You get 14. If 7x equals 14, you divide both sides by 7, and x equals 2. So it looks like my answer is going to have an x value of 2. From here on out, we're doing the problem just like we've done everything else. We're going to take what we solved for, we're going to plug it in to the original first equation. Not what we changed it to, the original first equation. So 2 for x plus y equals -9. I subtract 2 from both sides. Y equals -11. So it looks like the solution is 2, -11. Now I'm going to check it. Meaning I'm going to take the original second equation. For x, I'm going to plug in 2. For y, I'm going to plug in -11. And that all should equal 32 because the original second equation said 5x minus 2y equals 32. 5 times 2 is 10. So you can do just 2a's. You can ignore the negative sign here and do 2 times negative 11, which is negative 22. But then you're doing subtracting the negative, which is the same as adding. Or you could keep this negative 2, this negative sign with the 2. Negative 2 times negative 11 is positive 22. So 10 minus negative 22 or 10 plus 22, either way, it equals 32, and that checks. And that was the first problem. Second problem was 3x plus 2y equals negative 9. And x minus y equals negative 13. So again, there's a few things I could do here. I could multiply the entire second equation by negative 3. That would give me opposite coefficients for the x. That would give me 3x and negative 3x. Or I could multiply just 2. Okay? Since I did the y's last problem, I'm going to do the x's here. I want these to be opposite, so I need to multiply by negative 3. So that gives me negative 3x. Negative 3 times negative y is positive 3y. And negative 3 times negative 13 is positive 39. Okay? So now I'm going to put a line through that equation. I learned the hard way. I kind of am going to put the line through kind of the top of the equation because I'm not using it. But when I go back to plug in or check, I'm going to need to use it. And if I put the line right through the middle here, I can't tell what my signs were. So this is now my first equation, right? And this is my second equation. 3x and negative 3x, when I combine those terms, cancels out, I get 0. 2y and 3y gives me 5y. Negative 9 plus 39 gives me positive 30. So y equals 6. Again, now I'm doing just like I did before. I take the original first equation, taking out the y, because I just solved for y, plugging in 6. 3x, 2 times 6 is 12, equals negative 9. I'm going to subtract 12 from both sides. 3x equals negative 9 minus 12 is negative 21. So negative 21 divided by 3, x equals negative 7. So it looks like my solution is x is negative 7, y is 6. I would, if you were my student, be ensuring that you're writing all of this down as I'm doing it, because this is your homework check, right? This is what I'm going to be checking. If you have me next class, I'll be checking it next period. If you have me tomorrow, you're checking it tomorrow. Speaking of checking, I actually have to check this now. I'm taking the original second equation, which was x minus y equals negative 13. X we found was negative 7. Y we found was 6. Negative 7 minus 6 is negative 13. It checks. Problem number 3. 2x plus 5y equals 3. Negative x plus 3y equals negative 7. Wow, it would be difficult to get that 5 and the 3 to cancel out. Much easier to get the 2 and the negative 1 to cancel out. Since this is already negative and there's a coefficient of 1 there, basically. Remember, coefficient means the number in front of the letter. I'm going to multiply everything by 2. 2 times negative x is negative, oh my gosh, right, negative 2x. 2 times 3y is positive 6y. 2 times negative 7 is negative 14. So again, I'm going to put a line through that equation. That's the one I'm ignoring for right now. But I'm not putting it through the middle of the equation, so I can go back and see whether they were positive or negative signs. Okay? 2x and negative 2x, they combine to cancel out. It's 0. 5y and 6y combines to get 11y. 3 and negative 14. I have $3, but I need $14. What does a negative 14 mean? I think of it like money because it helps me. So I have to borrow $11 from somebody. If I need 14, and I have 3, I need to borrow 11. There's announcements. Telemarketers are calling me from Florida. I decided not to make the announcement. So if 11y... What?
No, I did a pop on purpose.
Right, I don't think they're saying. I think they changed it. So 11y equals negative 11.
Please pardon this interruption. At this time, we are going into stay put. This is a stay put. Any students or staff who are in the hallways or common areas, please move to your classrooms or an office area. Again, we are going into stay put. You may continue your planned activities in the classroom. We will let you know when we are cleared. Thank you.
Because that's what you do. We're going to keep teaching. Okay. We're recording. We're in a stay put, which means we are staying put. If you need to throw something out, you can get out of your seat. Okay? We are not leaving the classroom. Okay? Yes. If this turns into an emergency situation, well, there'll be audio recording of what happened in this classroom, and we will leave. And we will just let it keep playing. So, y equals negative 1. Negative 11 divided by 11, y equals negative 1. I'm going to plug this back in. You know what, but just in case we have to evacuate, I should probably make sure I have my purse handy and my roster. Stay puts can change. Okay. So now, I'm going to take the original first equation. 2x plus 5y. And I'm plugging in the negative 1. Five times negative 1 is negative 5. So actually, I can change this plus a negative 5 to just minus 5, correct? Okay? I'm going to add 5 to both sides. So 2x equals 8. And if 2x equals 8, x equals 4. I kind of used up all my room on this board. So I'm just going to check it. Oh, wait. Do it that way. My original second equation was negative x plus 3y equals negative 7. What did I come up with for x? Because I can't see it now. 4, since nobody's helping me. So negative x, negative 4 would be negative 4. Plus 3, what did I come up with for y? Negative 1. Equals negative 7. Negative 4, 3 times negative 1 is negative 3, is negative 7. Negative 4 does equal negative 4 minus 3 does equal negative 7. It works. Okay, so you should be writing these down.
At this time, we will return to our normal procedures. Today we practiced the stay put event. We would use this process if there were concern in the community that might impact our school. The important part of a stay put is that you are in an enclosed location and you stay there even if the bell rings until we return to normal procedures. Thank you for your cooperation in helping our school keep everyone safe. Thank you.
You can go back to working in the hall. Okay, did we get this one down?
Yeah.
Those of you who are working in the hall may go back to working in the hall. Okay? So that was problem 3, correct? So, problem 4. So, here's what I want to point out to you. So, I'm going to keep sticking with what we're doing, which is multiply to get rid of variables. Okay? Technically, you could divide here. You could divide this whole equation by 4, correct? And you would get negative x minus y equals negative 2, and then these would cancel out. I'm not going to do that right now, because my experience is there's a lot of different rules here, so the more we can keep the rules the same, the easier it's going to be. So I'm going to get these to be opposites by multiplying by 2. I could have gotten these to be opposites, the y's to be opposites, by multiplying by 4, but 2 is a smaller number. It's the same thing. If I can use smaller numbers, I'd rather do that. 2 times 2x is 4x. 2 times y is 2y. 2 times 3 is 6. So I'm not using that equation. I'm using these two. Negative 4x and 4x cancel out to get 0. Negative 4y plus 2y gives me negative 2y. And negative 8 plus 6 are combining terms. Negative 8 and 6 combine to give me negative 2. I divide both sides by negative 2, and y equals 1. Okay, now we're going to plug in. We're going to plug into the original first equation. So 2x plus y equals 3. So 2x plus, instead of y, we have 1, equals 3. I subtract 1 from both sides. 2x equals 2. Because 3 minus 1 would be 2. And x equals 1. So it looks like my solution is 1, 1. That's pretty easy to check. Negative 4 times 1 is negative 4, correct? And then negative 4 times 1 is negative 4. Oh yeah, negative 4 minus 4 does equal negative 8. 5 and 6 get more complicated because I have to do something to both equations. There is not an easy way to just multiply something by one equation. Okay? If I multiply the top equation by, and I'm going to use negatives so something cancels out. But if I use negative, see how this is 5 and 3 and this is 5 and 3. So if I use 3 here and 5 here, then I'll get some 15s. Okay? But if I use, or 5 here and 3 there. There's a lot of different things you can do. I'm going to just multiply the top by -3 and the bottom by 5. That's going to give me 15 and 15. Doesn't matter what happens to the y's, I just need one thing to cancel out. But could have done -5 and 3, and that would have given me -15s on the y's. That's why this gets so tricky. I think on your test you only have one where you have to multiply both equations. So -3 times 5x is -15x. And -3 times 3y is -9y. And -3 times -10 is +30. For the second equation, 5 times 3x is 15x. And 5 times 5 is +25. And 5 times -6 is -30. These cancel out. -9y plus 25y is +16y. But 30 and -30 also cancels out, and it's 0. Be careful, a lot of kids see 0 and they start thinking like no solution or something. It's not. 0 divided by 16 is the same as 0. Any fraction with 0 as the numerator is 0. So my y value is actually 0. I'm going to take that 0, I'm going to plug it in for y for the original first equation. I get 5x plus 3 times 0 equals -10. 3 times 0 is 0. So 5x equals -10. I divide both sides by 5. X equals -2. And now I'm going to check it using the original second equation. 3 times -2 is -6. 5 times 0 is 0. -6 is equal to -6. It checks. Okay? Number 6. I think there's about 8, 10 different things I can do here. So I can multiply this first equation by 3 and the second equation by 2, and that's going to give me 6 x's, right? We'll make one of them negative, one of them positive. They'll cancel out. Or I can multiply the top equation by 4 and the bottom equation by 3, and one's already positive and one's already negative, and they'll both have 12 y's, and then those will cancel out. That sounds like what I'm going to do. So I'm going to multiply this by 4 to get 12y here, and this by 3. 4 times 2x is 8x. 4 times 3y is 12y. 4 times 14. Oh no, I probably need a calculator. So that's 6, 4, 56, is that right? Didn't need a calculator. Look at that. Okay? Now the 3's. 3 times x is 3. 3 times 3x is 9x. 3 times negative 4y is negative 12y. And 3 times 4 is 12. These cancel out, correct? 9x plus 8x is 17x. 56 plus 12 is 68. And I actually remember, because when I was doing the homework yesterday to put it on Google Classroom, I kept messing this one up. So I actually remember that 68 divided by 17 is 4. Because I did this problem like 4 times to get it to work. How did I know that I was doing it wrong? Because when I went to check it, I wasn't getting the right answers. Also, in some cases, I was getting fractions, and that just didn't look right. So now, I'm going to follow the steps I followed before. I'm going to plug it into the original first equation. Two times 4 is 8, plus 3y equals 14. I subtract 8 from both sides. 3y, 14 minus 8 is 6. Y equals 2. So it looks like my answer is 4, 2. I'm going to check it. 3 times 4 is 12. Okay? 4 times 2 is 8. 12 minus 8 is equal to 4 if jumps. 7 and 8, it says you do not need to solve, I just need to write the equations. 2 times a number plus 3 times another number equals 13. Okay? Well, I don't know, I gotta read that again, but I got that something equals 13. 2 times a number plus 3 times another number. Well, we keep using x and y, so 2 times a number, I'm going to call that number x. Plus 3 times another number. I'm going to call that y. Okay, that works. 2 times a number, 3 times another, equals 13. The sum of two numbers is 7. Oh, two numbers added together equals 7. That's how I would write the system. From there to solve, I would either need to multiply the bottom equation by -2 to cancel these out, or the bottom equation by -3 to cancel these out. But it just said to write it, it said to solve. Okay? Next one. And it says it here also, define a variable. Define a variable, I'm going to say it number 8, just means tell me what letter you're using. It is easiest to do these if you don't, like the first one I used x and y because there was nothing special about the words, it was just 2 numbers. But the next problem talks about washing and vacuuming cars. So I'm going to say that washing cars, I'm going to use the variable w, and vacuuming cars, I'm going to use the variable v. Oh, that's going to make sense then to me. Okay? She washed 5 cars and vacuumed 4. So she washed 5 cars and vacuumed 4. And for that amount of money, she raised $38. Byron made $28. Oh, he made $28. He washed 4 cars. So he washed 4 cars and he vacuumed 2. That's my system of equations. I did not say you needed to solve it. I just said you needed to be able to write it. Are there any questions on this work?